I think we are live. Okay. So let me give one more second. Okay. So good evening, everyone. How are you guys? Hope you are doing good. So here we are with our question discussion on KTG and thermodynamics. This is part number 2. So today also we are going to cover some very conceptual, very deep conceptual questions. Okay, that has the probability to be asked in the upcoming examination. Okay, like in JEE Mains and NEET. So we have discussed some of the questions based on Carnot theorem and work done in different processes in the previous lecture. Today we are going to cover more and more detailed question based on the process, okay, and based on Carnot engine. And specifically, we are focusing on the molar heat capacities questions, okay, in which there is no defined processes there. Got it? So firstly, we will see some easy question, then we will increase the level of question. Now, very first question on your screen is this. A sample of gas at temperature T is adiabatically expanded to double its volume. Okay. The work done by the gas in the process is. So here the process is given to you, which is adiabatic. Just a second. The process is given to you as adiabatic. Now, it also says that the volume is double. Okay, this is the gas which expanded to double its volume. The work done by the gas in this process. So I'm giving you 2 minutes to solve this question. Okay. So try to solve this question. Let me know the answer. And any one of you can please let me know if we are live on the YouTube or not. Okay. And please be responsive in this session because more you will respond, more you will learn. Got it? So anyone solving this question? I hope you are trying to solve this question. Okay. Meanwhile, I will discuss this question. You will try solving it. Okay. And you find the answer. Let me know in the chat box. So first of all, this process is adiabatic. Adiabatic process. So for adiabatic process, we know that the relation between pressure and volume is PV raised to the power gamma is equals to constant. Okay. Now we also know that the work done in the in this process is given by work done in adiabatic is given by P1 V1 minus P2 V2 divided by gamma minus 1 or R upon gamma minus 1 and it is mu R. Mu will also depend on the number of moles. So I'm writing it for 1 mole. So mu R upon gamma minus 1 T1 minus T2. Okay. So here in the question you will see in the answer section the term is given to you in terms of R and T. So we have to apply this formula. Okay. But for that formula we need to know the final temperature. What is the final temperature? Initial temperature is T. Then it has been expanded. Then what is the final temperature? So we know that PV raised to the power gamma equals to constant. So we can write it as, let me change the color of pen today. So this we can write P1 V1 raised to the power gamma, P2 V2 raised to the power gamma. Okay. Now you can say that P1 by P2 is equals to V2 by V1 raised to the power gamma. Got it? Now we know that also that for ideal gas, PV is equals to nRT, where n is the number of mole, or you can also write it as mu RT. Got it? So finally, what do we have? We have P1 by P2, V2 by V1 raised to the power gamma. And another equation that we have is PV is equals to nRT, where n is the number of moles. Okay. Now we're talking about only one mole, so n is equals to 1. So from this process, we can say that P1 V1 is equals to RT1 and P2 V2 is equals to RT2, because R is the universal gas constant, so it will remain constant. Now if you take the ratio P1 by V1, P2 V2, it will become T1 by T2. Again, you can say that P1 by P2 here is T1 by T2, or we are interested in T1 by T2. So we will replace this pressure, because pressure is nothing given in the question about the pressure. Okay, only volume, it has to be said that volume become doubles. Now, so P1 by P2 is equals to T1 by T2, V2 by V1. We put this value in this equation number 1. So it will become, now P1 by P2 in replacement of P1 by P2, we have to write T1 by T2, V2 by V1. T1 by T2, V2 by V1. V2 by V1 raised to the power gamma. So T1 by T2 that we have is V2 by V1 raised to the power gamma minus 1. So this you can remember this relation for adiabatic process, that T is directly or constant V raised to the power gamma minus. Okay. So this you can remember, or simply this you can remember for two process. Now T1 is T, which is given to us. T2 we need to find out for the work done purpose. V2, it has been said that the gas is being double, the volume of the gas being double. So the V2 is 2 times of V1. It is V1 gamma minus 1. Okay. V1 and V1 will cancel out. So what do we have? We have T2 is equals to T upon 2 raised to the power gamma minus 1. Now, what is given above for gamma? It is 3 by 2. Okay. So gamma is 3 by 2. So we can write it as 2 raised to the power 3 by 2 minus 1 will become 1 by 2. So T2 will become T upon root 2. Okay. Now work done is R upon gamma minus 1 into T1 minus T2. Now gamma minus 1 same here will become 1 by 2. So will become 2R. Now T1 is T minus T2 is, what is the value of T2 that we have find out? It T by root 2. We take the LCM, or simply what you can do, you can take T as common and multiply 2 inside. So it will become TR 2 minus root 2, because this will multiply with 2. This 2 will multiply inside. So here it is remain as it is. And this 2 is nothing but root 2 into root 2. So one of the root 2 is cancelled by this. It will become minus root 2. So work done that we have here is TR into 2 minus root 2. So what is the option? Work done here is RT or TR is into 2 minus root 2. So this option is the correct one. So clear hai? Everyone? It is clear to everyone? Just let me know in the chat box if you have any kind of doubt in this. Okay, I'm moving on to the next question. This a very simple question. So in this question, the pressure of a gas changes linearly with volume from A to B. So from A to B, this is a process given to us, and the pressure is, let's say, you can say it is directly proportional to B because it is varying linearly. Okay. So pressure of a gas changes linearly with volume from A to B as shown in figure. Now, if no heat is supplied to or extracted from the gas, then change in the internal energy of the gas will be. So what is the change in the internal energy? Okay. So here some key point I will like to mention here. The pressure of the gas changes linearly, and if no heat is supplied or extracted from the gas, then the change in internal energy of the gas has been asked. So I'm giving you 1 minute to solve this question because it worth for only 1 minute. Okay. So try to solve it. Try to relate what is this process. No heat is transferred or no heat is taken out from the system. Okay. Heat transfer is zero. So in which process the heat transfer is zero? So student of JNV Ramnagar, are you here? Because you guys are not responding here. Come on, you are the champ. And same for the student of JNV Bhavnagar. Okay. Please let me know if you have any kind of doubt in the previous one or in this session. So try to solve this question and make this session to be interactive. Okay. So try to be responsive. Okay. So try to solve this question. Okay. So I hope you are doing this. Meanwhile, I am solving this for you. So if no heat is supplied or no heat is extracted from the gas. So that process is if heat transfer delta Q here is zero because there is no heat transfer to the system. Okay. And from the system. So we can say that the net heat transfer is zero. We can say that this is nothing but the adiabatic process. Adiabatic process. Okay. So for adiabatic process, what we can say delta Q is zero. So if you apply the first law of thermodynamics, first law of thermodynamics. So what is that? It is delta Q is equals to delta U plus W. Now if there is no heat transfer, so we can say delta Q is equals to zero. So all the work done here is minus of change in internal energy. So whatever the work you will do, it will going to change the internal energy. Or you can say that work is done on the expense of internal energy because there is no heat is transfer and this gas is compressing. This is gas is compressing because pressure is increasing, volume is decreasing. So how this gas is able to do work if there is no heat supplied to it? So it is doing work on the expenses of its internal energy. Got it? So more specifically, I would like to write it as delta U is equals to minus of W. Okay. And we also know that the work done, this diagram is PV diagram. So for PV diagram, work done is the area under PV diagram. This PV diagram we denoted by one term, which is indicator diagram. Okay. So what we need to do, we need to calculate the work done simply. Work done here is area under the PV curve. So area under the PV curve is this one, this complete. So here, if you will see, this is the rectangle, this part, and above part is the triangle. So this work done is the sum of the area of this triangle and this rectangle. So for the area of this rectangle, the length is starting from 50, ending at 200. So difference is 150. But one thing you need to focus on, that volume given here is in centimeter cube, cc. So you need to convert, because option is given in joule. So you need to convert it into meter cube. So 150 into 10 raised to the power minus 6 meter cube. Okay. Multiply with this, this height, which is 10. But pressure is also given to you in kilopascal. So we need to convert it into Pascal. So 10 kilopascal will become 10 into 10 raised to the power 3 Pascal. Plus area of this triangle, which is half into base into height. What is the base? Base is same as the length of this rectangle, which is 150. Multiply by height. What is the height? Anyone can tell me? What is the height of this triangle? So height of the triangle is from 10 to 50, which is equals to 50. Now same thing you need to do here. You need to convert this 150 because it is the volume. So you have to convert it into meter cube, multiply with 40 kilopascal, which is 10 raised to the power 3. Now this 3 can cancel out 3 power of this. Same here. It will become 1500 115 to 10. Where this 10 is come from? No, this 10 is extra written here. Okay, it is 10 into 10 raised to the power 23. So 150 into 10 will become 1500, 10 raised to the power minus 3. Plus this 2 will cancel out this 40, 20 times. So 20 into this will become 3000, 10 raised to the power minus 3. So you can say this 4500, 10 raised to the power minus 3. So it will become 4.5 joule of work. But here work is not has been asked. So in hurry, what you will do, you will take this option. Okay. But now you need to be careful. After you get this answer, you first need to check what is the question. So in the question, there is a change in internal energy of the gas is been asked. And we know that change in internal energy equals to negative of work done. So whatever the answer we have to multiply it with minus. So delta U we have minus of 4.5 Joule. So option D is correct. Okay. So I hope you got it. Now, if you have any kind of doubt, let me know in the chat box. Na? Okay. Now this one. A Carnot engine whose sink is at 300 Kelvin has an efficiency of 50%. By how much should the temperature of the source be increased so as efficiency becomes 70%? Very simple. Try to solve it. Giving you 2 minutes. Okay. 2 minutes is sufficient to solve this question. Meanwhile, I'm drawing the important extract of this question. This is the heat engine we have. Some work is done. Some heat is extracted, let's say Q1. And Q2 is supplied to the sink. This is our sink. And this is our source. So engine take the heat from source, give it to the sink, and some of the work is done. Okay. Now heat supplied to it is. Now this is the Carnot engine firstly. So we know the formula of efficiency of Carnot engine. So we can say that if the temperature of source is, let's say, T higher and temperature of sink is T lower, we already know T lower is given to you as 300 Kelvin, temperature of the sink. Okay. Now this is not known to you. So we can apply the formula that eta is equals to 1 minus T lower upon T higher. Now eta is 50%. It is given in terms of percent. You need to convert it into the actual value. So 50% will become 1 by 2. So 1 minus T lower, which is 300 divided by T higher, is equals to 1 by 2. By doing some calculation, you will like to know 300 by TH is equals to 1 by 2. Because this 1 by 2 we have taken here and this will go here. So 1 minus 1 by 2 will become 1 by 2. So T higher is nothing but 600 Kelvin. But for what case? When eta is 50%. Okay. Now, how much should the temperature of the source be increased so as efficiency becomes 70%? Which means we are increasing the temperature of source only, not the sink. So the temperature of sink will remain constant. Now, let us consider the temperature of source is T dash now. After increment, it become T dash. So what is the efficiency? So eta dash is nothing but 1 minus T 1 minus T lower over T higher. So it will become 1 minus T lower divided by T dash. Okay. Now eta dash is given to you now 70%. So 70% is 70 by 100. So you can write it as 70 upon 100, which is 7 by 10. So from here you can say that T lower, which is given to you 300 Kelvin, divided by T dash is 1 minus 7 by 10, which will become 3 by 10. Okay. So this will become 100. So T dash, what you have as 1000 Kelvin. Now most of the student, what they will do, there are four options, let's say 1000 Kelvin, 400 Kelvin, 300 Kelvin and 600 Kelvin. So what they will do, they will just tick the 1000 Kelvin because they got the answer that final temperature is 1000 Kelvin. So this is the correct answer. No. Firstly, I am again telling you, you need to, whenever you find out the solution, just read the question once again and try to find out what has been asked. So in this increased, okay, temperature of the source be increased. So increment has been asked, not the final value. So initially, T initial was 600 Kelvin of the source and T final you have as 1000 Kelvin. So what is the increase? Delta T. It is T final minus T initial, which is given as 400 Kelvin. So this is the correct option. So 400 Kelvin, the temperature need to be increased of the source to get the efficiency from the same Carnot engine of 70%. Got it? I hope you got it. Now move on to the next question. This one. The student of JNV Ramnagar, try to solve it. I think you are Shiva, na? So try to solve it, Shiva. Another student also. I'm giving you 1 minute, or let's say 2 minutes. Okay, try to solve this and let me know the answer. So if any one of you that has been joined through this Zoom meeting, so if you are giving replies on YouTube chat, so that is not applicable to me. So if you have any query, any doubt, or if you solve the question and you got the answer, so try to write it in the Zoom chat box. Okay, not in the YouTube comment box. Here. So the question says to you that an ideal gas is expanding such that Pt square equals to constant. Now find the coefficient of volume expansion. Now we already covered it. That what is the volume expansion? We know that delta V is equals to V naught gamma into delta T. So volume expansion is given by delta V by delta T into 1 upon V naught. Okay. This is the volume expansion. Now for differential value, you can write it as gamma is equals to 1 upon V naught dV by dt. So try to think upon this dV by dt. How do you get it? Pt square is given to you. Ideal gas it is. Okay. So now in this question, Pt square we will consider as K. K is a constant. Now we are interested in dV and dt only. Got it? Now what we do, we would like to replace this pressure by volume and temperature. So for ideal gas, PV is equals to nRT, where N is the number of mole. So V you can say that, sorry, P will become nRT upon V. Okay. Now put this value, put it in 1. So what do you have? You have nRT upon V into T square, which is equals to K. So finally you will have as nRT cube equals to kV. ठीक है? Any problem here? यहाँ तक? I hope it is clear to you because simple mathematics is there. We have only used the ideal gas equation to replace the pressure with another terms like temperature and volume. Because finally we need to know this 1 by V naught dV by dt. Okay. Now, if you differentiate this with respect to temperature, what do you have? Differentiating equation number 2, you will say differentiating equation 2 with respect to temperature. So what do you have? You have 3 nr, or nr is a constant. So nr 3t square into k dv by dt. Okay, differentiation of t cube is 3t square and differentiation of v with respect to 2 is dv by dt. Okay. Now, if you take this 3nr t into t is equals to k dv by dt. Okay, so dv by dt we have find it out. We need to divide it by only volume initial. So initial volume is v, which you can replace by this. Okay, PV is equals to nRT. Got it? PV is equals to nRT, and n you can take it as 1 because this is whole is doing VR for 1 mole of gas. So N here you can put it 1. So it will become 3RT into T is equals to K dV by dt. Got it? Now, this will become 3RT into T by K is equals to dV by dt. Got it? Now, this T square, you can replace it by P by K. Got it? So here you can say this is 3RT T upon K is equals to dV by dt. Now from ideal gas equation, you can say that PV is equals to nRT, and if N is equals to 1, then we can say that PV is equals to RT. So RT के जगह we will write PV. So it will become 3PV into T upon K is equals to dV by dt. Now it will become 3PT upon K is equals to 1 upon V into dV by dt. This 1 upon V dV by dt is nothing but gamma, which is the coefficient of volume expansion. Now, if you put the value of P, which is K upon T square, from here, if you put the value of P, it is K upon T square. So put it here, it will become KT over T square. K and K will got cancel out. So it will become T and T will also cancel out. So gamma you will have here is 3 by T. Or one thing that we are missing, yes, where is this R? Okay, R has been vanished out. So 3 by T is the coefficient of volume expansion. Okay, got it? So gamma is the coefficient of volume expansion in this question, and we have find the value of it 3 by T. Now, I would like to revise this question to you that PT square is equals to K is the relation that is given to us. And this gas is expanding. So for ideal gas, because this gas is ideal gas, so we can apply PV is equals to nRT. And P finally we have write it as nRT by V. Why we are doing this? Because we need to find out gamma, and gamma is nothing but delta V, change in volume, is given by original volume gamma into delta T. So gamma is nothing but 1 upon V naught delta V by delta T. In differential form, it is 1 upon V naught dV by dt. So we have replaced this P with V and T so that we can easily differentiate it. So when we put it, it will become nRT cube kV. Now for easiness of the question, we have considered n is equals to 1. So nr, here you can also replace this n. Okay. So this will become r into 3t square k dv by dt. Now dv by dt we are interested in. So this will become 3RT into t. Now 3RT again from ideal gas equation, if n is equals to 1, then PV is equals to RT. So we have put the value 3PV, T by K. Okay. V we have taken this side. This is the original volume, 1 upon V dV by dt. This will become gamma. And this is 3PT upon K. We need to put the value of P, which is K upon T square. So this will come out to be 3 by T. I hope this is clear to you, everyone. So just a second. I need to take care of the time also, na? Okay, so I hope this question is clear to you. Now, that type of question has a tendency to be asked, na? The relationship is there. So you need to understand what you have to do. Okay. So this question I would like to focus on. It's a very important question, and it has been asked in JEE Advance, okay, in the previous years, and most of the chances is there that it will come, and some of the part wise, like only part A has been come in JEE main, or only the part B is come in JEE mains. Okay. So there is a rectangular box is given to you. A rectangular box has a movable and smooth partition. This is the partition which is movable and smooth. So there is no friction in this. Now, which can slide along the length of the box. Now, both chamber contain 1 mole of monoatomic gas. So for monoatomic gas, gamma is 5 by 3 at a pressure of P naught and volume V naught and temperature T naught. So initial values are P naught, V naught, T naught, and here also P naught, V naught, T naught. In the left hand side also, in the right hand side also. Now, the left chamber is slowly heated by an electric heater. So here you can say this is the electric heater which is provided by us. And we are heating this gas. So this chamber will heat up. Now, the wall of the box and the partition is thermally insulated. So this is very important. So these walls and this partition is thermally insulated, which means if we are providing heat to this section, this heat will not transfer to this section. Okay, so that is the important term. Now, due to heating, gas in the left chamber, like in this chamber, expand until pressure in both the chamber will become 32 P naught. Now determine the final temperature of the gas in each chamber and the work done by the gas in the right chamber, So this is our right chamber RC, and this is our left chamber. Got it? Now, what we are going to do, we are going to draw the final and initial conditions. So initial condition may we have the partition here. Okay. Initial volume, pressure is P naught, volume is V naught, temperature is T naught. Here also P naught, V naught, T naught. Now when we heat it up, what will happen? The gas will expand, getting up heat. So this will expand, the piston will slide, this partition will slide a little bit. So pressure here is, let's say, P, final pressure. Volume here, let's say, increase by V. So same, if the volume increase here by V, so this chamber has a decrement of same unit. So here the pressure is P, but the volume will become V naught minus V. Let the temperature here is T1 and temperature here is T2. Okay? Very simple. Now why I have written P and P same pressure? Because it is given in the question that the gas in the left chamber expand until pressure in both chambers become 32 P naught. So this P has a value of 32 P naught. 32 P naught. Okay. Now what we can do? We have to find out the temperature in each chamber, T1 and T2, and then the work done. Now we know that if this is the thermally insulated walls, so in this process, in the right chamber, which process can take place? Because pressure is somehow changing, volume is changing, temperature is changing. But what is not changing? Heat. We cannot transfer heat to the right chamber from left chamber because all the things are thermally insulated. So here the work is done by adiabatic process. So adiabatic process in the right chamber. In left chamber. Okay. So for that we can apply PV raised to the power gamma is equals to constant. So in this process, P1 V1, let's say, raised to the power gamma. Finally, it is P2 V2 raised to the power gamma. Now P1 is P naught, V1 is V naught, initial values. gamma P2 is 32 times P is given is V2 is the final value raised to the power gamma. Now, if you cancel this pressure here, we can easily cancel it out. This V naught raised to the power gamma, gamma is given to you as what? 5 by 3. So this is 5 by 3. Now it is 32. And you can, instead of writing it V naught minus V, we will write it as V dash. V dash you will have gamma. So it will easier for us to, na? So it will become 5 by 3. Now, what you will do? You will take the ratio that V naught by V dash raised to the power 5 by 3 is equals to 32. If you take the power on this side, so this power will inverse. So V naught by V dash will become, this will become 32 raised to the power 3 by 5. Okay. This is a simple analogy, simple mathematical operations. So V naught by V dash is equals to 32 you can write 2 raised to the power 5, 3 by 5. So this 5 and 5 will cancel. So finally V dash you will have as V naught raised by 8. Okay. This is the final volume. Now, what is the value of V? How much is the expansion? How much is the compression? So we can say that it is V naught minus V, final volume. V naught by 8. So V here will become 7 by 8 times of V naught. So this is the compression. Okay. So 7 by 8 times of V naught, this volume has expanded, and 7 by 8 V naught times this volume is compressed from V naught. Okay. Now again, we are going to use the same relation we have developed in adiabatic process between temperature and volume. So what is that? T1 by T2 is V2 by V1 raised to the power gamma minus 1. That we have also developed, na? Equation number 2. Again, T1 is T naught, T2 we need to find out. Let's say T2 is here. Now, V2. V2 we have already find it out. Now, V2 is the final volume. Okay. V2 is the final volume, not the expansion or compression. So final volume is V naught minus V, which we have V naught by 8. So it is V naught by 8 divided by V naught raised to the power gamma minus 1, which is 5 by 3 minus 1. So it will become 2 by 3. So T naught by T2, and we are applying this by on right chamber. So that is why we are considering the final temperature as T2. Got it? Now, V naught and V naught will cancel out. So it will become 1 by 8 raised to the power 2 by 3. Now we know that 1 by 8 is nothing but 1 by 2 raised to the power 3. Raised to the power 3. And here we have 2 by 3. So it will cancel out. So we can say that T2 is here is nothing but 4 times of T naught. Okay. So the final temperature of this chamber, right chamber, we have find it out. Okay. This is adiabatic process in right chamber. Right chamber. So right chamber में T2 we have find out as 4 T naught. Now for T1. Now what is happening in the left chamber? There is a heater which is heating up the gas inside it. Now, if it is heating, what kind of process it is? Because pressure is not on the constant one. Volume is also not constant. Temperature is not also constant. Heat is also provided by fluid. So we cannot specify any process to it. It is not isochoric, it is not isobaric, it is not isothermal because temperature is also changing. And it is not on it is not also the adiabatic because heat is given to this system. But one of the thing that is constant here, what is that? Tell me if you are able to do this. What is that process? That that thing which is not changing in the left chamber is the number of mole of gas. So 1 mole is present here. Whatever the expansion it, the number of mole will remain same because mass is conserved. Okay. So we can say that number of moles, number of moles in left chamber remain constant. So we can say that according to ideal gas equation, PV or P1 V1 is equals to nRT1 and P2 V2 is equals to nRT2. So from here we can say that P1 by V1, P2 by V2 is equals to T1 by T2 because N is constant. Okay. So this is for the left chamber. Okay. So for left chamber, the final temperature we have considered T1 and initial temperature was T naught. The P1 is P naught for the left chamber. Initial volume is also V naught. P2, which is what? P2 is the final pressure, which is 32 times of P naught, which is given to us. And V2 here is nothing but V naught plus V. And we have already calculated 7 by 8 times of V naught. It is T naught by T1. Now this P naught and P naught you can cancel out. So here you will have as V naught by 32 and it will become 7 by 8 V naught. So totally it will become 15 by 8 times V naught. T naught by T1. V naught and V naught cancel out. 8 for the 32. 15 into 4 will become 60. So you can say that T1 here is 60 times T naught. So this is the final temperature of left chamber also. Okay. Although we do not know what the process is, but we can always conserve the number of moles, and because benefit of that is we are able to find out the final temperature of the left chamber. Now, if we calculate the work done by gas in the right chamber, okay, because this gas is compressing the right chamber. So what is the work done? Okay, so we can say that work done by left chamber because it is compressing the gas. So what is the work done? So here we can say that whatever is the work done by the left chamber, it is the work done on right chamber. So work done by left chamber will equals to the work done in work done upon right chamber. So if you are focused on the work done upon right chamber, it will be given by thermodynamic equation, first law, which is delta Q is equals to delta U plus W. So delta Q is 0 in the right chamber because no heat has been transferred. So we can say that work done here is minus of change in internal energy. Now, change in internal energy is nothing but NCV delta T. N here is number of mole which is equals to 1. So it is CV delta T minus of CV delta T. Now we know that for monoatomic gas, CV is equals to 3 by 2 times of R. Okay. So work done will be minus of 3 by 2R into delta T, which is change in temperature. So initially the temperature was T naught and final temperature of this is 4 T naught. So it will become 3 T naught, 4 T naught minus T naught. So it will become 3 T naught. So work done here will be minus 9 by 2 times R T naught. Okay. So this is the work done in this process. So we have got all the answers. So if you have any kind of doubt, you can ask. Otherwise, the lecture is been over. Thank you so much for being attentive. And I wish you all a very wonderful day ahead. Thank you so much.